Hi, everyone. Welcome to Track D, AI and Machine Learning Summit. I'm Ed Dale. I'm a Emerging Tech Leader at EY Knowledge. Today's session is Catch Me If You Can, How to Fight Fraud, Waste, and Abuse Using Machine Learning and Machine Teaching with Cupid Chan. Cupid Chan is the managing partner of 4C Decisions. He's a very packed schedule today, so I'm going to turn it over to him. Thank you, Cupid.
Thank you.
1 second, 1 second. Hold on. Sorry.
Didn't get started.
Okay.
All good? Shall we start?
Yeah, can Cupid start now?
Okay.
Yep. Okay.
Disclaimer. This presentation session was prepared or accomplished by Cupid Chan in his personal capacity. The opinions expressed in this talk are the author's own and do not reflect the view of any United States government agency or department.
Good morning, good afternoon, or good evening, depending where you are geographically located. My name is Cupid Chan. Welcome to the Data Summit Connect 2021. And today we are going to talk about the topic of Catch Me If You Can, how to fight fraud, waste, and abuse using machine learning and machine teaching. But before we jump on to the topic, let me also share something with you about myself. I was the board of director and technical steering committee with ODPI in Linux Foundation. And last year, ODPI was merged with LFAI to form another new community called LFAI and Data. And why do I need to tell you about that? Because for this presentation, part of the section will actually rely on it's based on the publication that we had last year about human-centered AI. And before we jump on another topic, I would like to actually share with you a story of mine. One night when I prepare for this presentation, actually it is a real true story happened to me. One night when I prepare for this presentation, I got a LinkedIn request, like a friend request from Jacqueline Moss. I do not know who is she, but I see that we have 16 mutual connections. So I find out that maybe yeah, it's a legitimate friend from my connections. So I accept her request and becomes the connection in LinkedIn. So far, so good. We check a little bit, but something comes up very interesting. When she asked me, what do you do? I said, I help organizations to leverage the data they have and using AI and analytics. For example, using prevent fraud, waste, and abuse, which is exactly what I was doing at that night. And then she said, interesting. And I would like you to share with me in exclusive about yourself and what do you do in your industry? Hey, hold on. Didn't I just tell you that I actually help organizations to use the data and analytics? But anyways, I sincerely did not know what's that mean by exclusive. So I asked, by exclusive, you mean in what sense? And her answer was, yes, exactly. Wow, that really puzzled me. I'm not sure why yes exactly can answer my question, but I reply again saying, I'm sorry, but exactly what? This LinkedIn story to be continued, I guarantee that by the end of this section, you will know the end of what happened to Jacqueline Moss and myself. But let me start with telling you something like this. For the Catch Me If You Can, I actually get the idea from the movie Catch Me If You Can. And in the movie, Leonardo DiCaprio, he was a pilot, but he never attended flight school. He never attended medical school, but he's a doctor. And at the same time, he did never attend any law school, but he is a lawyer. Just like any classic plot, if you have a bad guy on one hand, you will have a good guy. And in this case, Tom Hanks is the good guy trying to catch Leonardo, which act like in the movie, it's Frank Abagnale, and trying to catch him because Frank Abagnale cashed $2 million false check. And now converted by inflation 40 years later, it's approximately $17 million right now. And for this reason, I have an idea. How about we use AI and catch me if you can this topic? So I find out that the title slide that I show you actually should change to something like that. Catch me if you can. and how to fight fraud, waste, and abuse using machine learning and machine teaching. Now, of course, if you use the fraud check to fake or to fool the banking system, it's a little bit old-fashioned. So that's the reason why Forbes did another survey like 2 years back about how the organizations are going to use data analytics technique to fight fraud. And as you can see that, nothing very unexpected, the exception reporting or anomaly detection. It's something that is very popular. But I want you to focus on artificial and machine learning approach, even though right now it doesn't have much adoption rate. However, take a look at that. In the next 1 or 2 years, organizations are expected to spend most of the adoption in machine learning and artificial intelligence. And when we are talking about fraud, there are different kinds of fraud. For example, credit card fraud, healthcare fraud, and identity fraud, they are the very popular fraud when we're talking about this topic. But take a look at that. Healthcare fraud costs about $68 billion every year. Way more than the other fraud in showing up here. You may ask, why? Why is that so high of a demand for healthcare fraud? What happened? And actually, if you take a look at the cake, the size of the cake of healthcare is much bigger than the other. So that's why even though you have only this, if you have the same percentage of that, you will have much bigger impact for that. So take a look at CMS, Centers of Medicare and Medicaid Services. And in 2018, it has more than $1 trillion budget. The cake is very big. And if I put this into perspective or compare to different countries, you can see that compares the GDP of different countries versus the budget for CMS, it's actually ranked 17 across the world. So compared to different countries, CMS budget, $1 trillion is approximately ranked 17 in the GDP. And that's the reason why the hacker, all the fraudulent folks around the world right now, they are trying to get a share of this cake. And in fact, not only them, but the news channel a few years back, they also make a report of Medicare funds being improperly paid of $60 billion. So we have a business case here. How are we going to fight fraud? For example, in CMS fraud using AI, the very first question we need to ask is, where is the data? Where can I get the data so that I can at least have my algorithm to build on top of? Don't worry, because CMS themselves actually publish a lot of open data for the citizen or anyone who is interested in CMS to download those kind of data set. And one of them is called Medicare Provider Utilization and Payment Data. And this set of data, starting from 2012, you can see that there are lots of related data for the providers. But another problem comes in when I look at the data, because the metrics that they provide, they are not always the same across different years. And at the same time, the attributes for the data set is also not correct, not consistent across different years. So the very first thing after you get this data is to clean up the data so that each year will align with each other in terms of the attributes and also the metrics. But even after you clean the data, you have one thing that you must notice, which is there is no fraudulent data in this data set. It only has what kind of doctors he or she is, and how many patients that he has, how much the provider are getting for that particular year. There is no fraudulent data here. So we reach out to another open data set from OIG, Office of Inspector General. And in this list of excluded individuals and entities, LEIE dataset, we will have a list of excluded individuals who may be because of committed certain fraud and then confirmed by OIG that he needs to stop his or her practice from this day to another day. So if I put it in a graphic, you will see something like excluded start day from this year or this day to the excluded days there. So if I notice that this particular doctor actually has a claim in the previous data, in the first data set of the Medicare provider utilization and payment data, I know that that is a fraudulent claim because he or she is supposed not to do anything to claim the federated funding healthcare program. But I take one more step further, which is I make sure that it's not only for that particular duration. I assume that this particular provider is being banned by OIG is because something that he did before. So I take 1 year before the excluded start date and then assume that anything in between 1 year before the excluded start date to the end of excluded date, anything that I can find in the first set of the data, Medicare provider utilization and payment data, if I can find any single line of transaction there, it is a fraud. After we understand the whole process of how to get the data in, you will see this very simple workflow. And in each of this recipe here, I am going to clean the raw data here by, for example, changing or correcting the name of the attributes so that they are consistent across all the years. And then after that, the LEIE database here, I then join together by the NPI, the National Provider Identifier. After this, I finally got a data set that I can work on the AI. Now, let's predict using machine learning. But something I want to tell you, while others may take days or weeks to train a model, based on my very rich experience in AI, I can build a model guaranteed with 99% accuracy within only 10 seconds. Are you ready for me to share with you what is that accurate model? Everything is not fraud. I predict everything is not fraud. My accuracy will be more than 99%. For those who understand AI and machine learning, they know that I'm cheating the system. And for those who doesn't know what am I talking about, let me share with you the confusion matrix here. Accuracy, yes, is one of the many different criteria to evaluate the effectiveness of a model. But when I take a look at the data, 54 million of the cases or observations are all together, but only 4,600 something. It's considered as fraud. When I plug all those in, even though I make all those fraudulent cases as non-fraud, my accuracy will be 100% minus 0.0086%, which is definitely more than 99.9%. But remember, what we are trying to achieve right now is to detect fraud. What good is it if I am going to predict everything is non-fraud, but with an accuracy, but I can never find the true fraud? That is not what the goal of this exercise. So that's why we come up with a problem. And this problem actually is not only for fraudulent case. It's called data discrimination for the minority class. For example, the manufacturing defect or some rare disease diagnosis or natural disaster. They are rarely happens and they fall into the very same category of data discrimination. Because of this, even when I have an AI model to train on that, there will be a bias. The bias is because I see so many different cases is okay. So it cannot really find out or overlook the pattern exposed in the minority class. In this case, it's the fraudulent class. It cannot really find it out because it's overwhelmed by the majority case. So you may ask, What can we do about that? The solution here is to use either decreasing the majority. In order to make the class balanced right now, we need to reduce the majority so that the ratio of the minority and majority would be more comparable. Or on the other hand, of course, you can decrease the majority or you can increase the minority by random sampling, by replicating the minority observation. Either one of the two cases will be very valid. But in this case, I am going to use random undersampling by reducing the majority. And the reason is very simple. Remember, we have already got 54 million observations. I actually do not need anything more to make this algorithm, to train this model. I actually need something smaller. And in this case, I can cut it smaller as 50-50, or I can have 40-60, or 30-70, or 20-80. It doesn't matter. The whole point here is we need to make the minority class and the majority class to be much more comparable. That is the goal of this random undersampling. So when I have done all that and try to plug that in using a 50-50 class distribution, plug that in using TensorFlow boosted tree classifier, take a look at that. Yes, you may notice that, hey, my accuracy, it's dropping from 99% to like 76%. But look at the precision. Precision 70%, recall 85 or 86%, and the area under the curve, AUC, is 84, which is actually pretty decent. If I can sacrifice of 100% of accuracy by training this using the TensorFlow boosted tree classifier, I actually can get a pretty decent precision and recall for the overall effectiveness of the model. So this trade-off is actually very valuable. And for those who know AI or machine learning, they would aware that this is something called supervised learning. But supervised learning in detecting fraud has its limitation. First of all, you are not always getting attacked data. And in this case, we are getting two different data sets and try to come up with our own logic to tag the fraudulent case. And secondly, because supervised learning relying on some data, some tagged data, and for the emerging anomalies, it's actually very hard to capture because it's actually not there yet for the people to tag and label the data. So that's the reason why there is a limitation of the supervised learning, and we need to find maybe another way to compensate that, to complement that. What is the other thing? Unsupervised learning. Versus supervised learning, unsupervised learning is a very good approach to detect outlier. But remember, while fraud is really a criminal, anomaly or outlier is only a suspect. It provides a good starting point for us to like investigate what is going to happen, or maybe a hint for us to start. However, it doesn't mean the outlier must be something committed to the fraud. That is something we need to remember. Now, if we take a look at outlier, can you tell me what is the outlier in this data set? It's very hard because we are not orienting the data in the sense that we can spot the outlier correctly or easily. But if I plot the X and Y in this two-dimensional graph, you can easily point it out. This is the outlier. And we can start from this outlier and see whether this is a true, legitimate, fraudulent case. Besides that, we have different ways to find out or consider what is an outlier. And in this case, I know we're not in person, we're not really doing this conference in person, but let's try to be a little bit more interactive here. P1, P2, P3, which one do you think is an outlier for this case? Give you 2 seconds. You got your choice? So if you pointed to P1, you are correct, because by the nearest neighbor approach, it's based on the distance. how far or how close the data point is away from the other neighbor. So if you point P1, you're correct. However, if you point both P1 and P2 are the outlier, you are also correct. But in this case, we are using density-based approach. We are basing on the density to find out what is the outlier in the whole data set. An outlier is only one way that unsupervised learning will provide to start dealing with the fraudulent case. Another very effective way is unsupervised clustering. And in this case, you can see that we have like an original unclustered thing. And then at the same time, by roughly divided into 3 groups, we can also see they can be clustered in 3 distinct data here, or cluster here, data group here. So it's actually the matter of how or will you be able to spot the pattern of the data. And when I think about that, I always think about this picture. You may wonder, what is this picture about? Take a look.
This may look like just a jumble of old painted plastic and wire, but when you take a step back, you see it for what it really is, a remarkable sculpture suspended in mid-air.
So I am always going back to this video when I think about unsupervised learning, because all the data points, just like what you see in this video, they are hanging there, but only at certain angle and certain distance. When you look at that, you will finally you see what is this about. So in unsupervised learning, instead of we taking step forward or backward, looking at different angles, we are actually asking the algorithm to look at different angles and step backward and sideways for us, so that it can detect this kind of pattern, so that it can detect that kind of pattern in the data to really find out the outlier or clustering the data effectively. So the whole goal here is we need to understand the unsupervised learning approach is not really to find out what is the fraud, but at least in the for the start, it will provide you a hint. How do you really start the investigation? Now, let's go to the very third approach that I'm going to cover in this section. But before I disclose what is this third approach, let's take a look at this lady. And because you must know her in order to understand this third approach. Who is she? So I have few options here. Let's see whether you can pick the right one. Number one, she committed a $100 million fraud in European bank last year by guessing the admin password using an AI algorithm. And number two, she is actually a man dressed in disguise to fool the airport security, smuggling 500 fake passports in US last year with valid passport numbers produced by AI. And number three, this person invented the third approach that I am going to talk about. So which one do you think she is? 3, 2, 1. Actually, none of them. She actually not even a real person. This is an image generated by this third approach called GAN, Generative Adversarial Networks. And how is this GAN working? Is instead of one network, it has 2 networks. One is called generator, and the other one is called discriminator. And the generator is trying to capture the real sample from daily life, trying to learn from it, and then generate some fake samples. And by these fake samples, the discriminator will determine whether is it right or not. We then, based on the correctness of the guessing of the discriminator, we will then fine-tune the 2 models here. And then when this process keep going, we will have a very efficient and very smart generator being created. And you may heard about that. if we feed for example, if we feed the cat's data or cat's picture in the generator will try to really produce some fake samples, and the discriminator will try to determine whether it's fake or not. At some point, the generator will be so good that the discriminator cannot even tell whether it's a real sample or fake sample. And we throw away the discriminator and keep only the generator. This is what the gang is about. When we plot in a graph, we can think about all this, like a blue cross right here, they are the real sample. And the yellow dot here, they are the fraudulent case. And right here, the orange triangle is the generator trying to produce some fake sample to fool the discriminator. So this is how it is going to represent the gang framework or the gang architecture. But you may ask, Cupid, I think we are talking about fraud, waste, and abuse, right? Why do you suddenly bring up like image generation? Yes, it's interesting, but what good is it in order to help to understand fraud, waste, and abuse? Don't worry, I'm going to tell you why is it related. Think about this. Instead of generator and discriminator, I replace them with Tom Hanks and Leonardo DiCaprio. And then instead of the cat's image, I gave the generator a fake checks or some real actual financial data, so that Leonardo can generate a fake check or fake data. And this fake data is going to feed into this discriminator so that the discriminator will try to decide whether it is or it is not true or not real. And at the end, remember, in the image generation, we throw away the discriminator, and then we keep the generator so that it keeps on generating some very real cat's image, for example. But in this case, when we are going to apply the same architecture, we are going to throw away the generator and keep the discriminator so that the discriminator can detect when it finds a fraud. When we plot in the like diagram, just like what we did just now in the regular gang, this is called complementary gang. And what's happened is, instead of creating a very similar real thing in this area, we are going to create a fake sample or generate a sample as the orange triangle in between the fraudulent data and the actual benign case. So by doing that, we are actually helping the discriminator by detecting that, because the discriminator now, instead of detecting anything in sitting in between in the same group, it needs to detect anything that is outside or in between the boundary of the real actual case or the fraudulent case. So that will make the whole discriminator to be trained much more effectively. And now, if we take a look at what we have talked so far, we have talked about supervised learning, which is using the tag data and then try to, based on the tag data, we are going to predict what kind of observation can be a fraudulent case. We also talk about unsupervised learning. And in the unsupervised learning, we are providing not even one single label or tag. We are just letting the algorithm to take a look at the data and then find the pattern for us automatically. And third, we also talk about the semi-supervised learning using GAN. So far, everything we have talked about, it's machine learning. Remember that last year in Linux Foundation, LF AI and data, we have a publication about human-centered AI. And one of the big topics that we find out, if we really want to achieve human-centered AI, we need to not only consider machine learning, but just like any education system, we also need to consider teaching. And in this case, machine teaching. And how is it going to work in machine teaching in our section? Let's take a look at that. I actually had a YouTube video to explain machine learning by divided into 7 different steps on this, from business requirement to data gathering, data preparation, which we also cover in this section, to pick the right algorithm, training the algorithm, evaluating that, and other consideration. But look at that. When we look at this, we are focused more on machine learning to really make the algorithm smarter. But human, it's actually sitting outside of this. So for example, the data expert or the annotator, they annotate the data and then we provide this to the data gathering stage. At the end user will enjoy or really receive the service provided by the result of this machine learning. However, when we take a look at that, this is actually a pretty silo exercise. And we cannot really get everything to be in the same picture and put human in the center if we keep on getting this kind of separation between the human and the machine. Let's look at that. What if we redraw this picture? We redraw this picture so that the human will be put it into center. And then instead of having the human using the brute force to annotate the data so that the algorithm can take in and then the data can take in and then we can come up with the algorithm with the model, we actually put teaching in the input, machine teaching in the input. How does that work? So we can actually put like an algorithm here and then try to, unless there is a doubt in the robot of how the data looks like, the robot will keep on annotating the data. And in fact, if you know that, especially for supervised learning, this is a very important but time-consuming exercise for the whole machine learning process. But if we put robot here, if we put machine here to do the annotation, and if and only if there is an exception, that it says, hey, I always know that a cat will have a pointy ear, but I find out something, I'm not sure whether really it's a cat. So in this case, human will jump in. Human will jump in and say, oh, that's called Chihuahua. This is actually a dog, not a cat. And here, machine will then update the model to recognize, oh, now I know that it's not only pointy ear, but this kind of a picture that if I see that, this kind of animal, if I see that, it is a dog. So it's updated. Human teaches by interacting with the machine. That's one way to make the machine teaching possible. But not only the input, also the output is possible. Let's see that. Let's say in the output training, of course, the model will try to come up with some decision. However, here, if it detects something, but it's not quite sure, it will then pop up a notification or message saying that, hey, Dr. XXX usually is not that like has that kind of like a volume of this doctor visit. But last year, this year, we detect an unusual claim patterns, a potential fraud. The robot cannot really 100% saying that it's a fraud, but it provides a reason. Especially if, for example, the number of patients has jumped 25% more than the past 5 years running average. If you take a look at that, then the robot may find out something, then the human comes in and try to provide more information and say, hey, you know what, Dr. XXX is actually okay because his colleague YYY had a maternity leave for 9 months. So that's why XXX just picked up her patients in the interim. So that is how the user can really teach and collaborate with the machine learning algorithm, the result of that, and teach back to the algorithm and say, this is actually all right. And by doing this I think is the more complete loop when we are talking about human-centered AI, especially for machine learning and teaching. And practically, how does it work? Of course, I think something that we really want to make sure is you don't want to design a system with like a different interface. So for example, here we have a dashboard, and in this dashboard, we have different things right here for the algorithm has already determined, oh, this is a fraudulent case and this is not, all right? In the very, very same interface. If the user, we are talking about machine teaching, right? If the user can pick which case and then confirm this is actually a good scenario, you're predicting it right, or it changed to reject the result of an algorithm saying that, no, this is actually not good because of that reason. So all this data captured right here can then be fed back to the algorithm. And this algorithm will then learn and become smarter. So the point here is, if you are going to design a human-centered design with machine teaching, one thing very important is to come up with that solution in one single interface, instead of trying to let or ask the user to go into different systems or interface in order to achieve that kind of goal. So that is the main point of machine teaching. Now, let's take a look at our LinkedIn story that we talked about that's in the beginning. So what happened is, I really have no clue who is this Jacqueline Moss, and I decide to ask my most knowledgeable friend for help, which is Google. So I find out that Jacqueline Moss is actually a real person. It's not fake, but she is approximately 80 years old. An 80 years old lady getting on LinkedIn and trying to connect with me, chit chat with me. I think it's a little bit skeptical. And actually at that point, I have already determined that she is actually a scammer instead of a real Jacqueline Moss contacting me. So when we go back to the conversation, you remember that I really sorry about exactly what I asked this question. And then she replies, what do you do in your place of work? And the profitable it is. First of all, I think it's kind of like the grammar is a little bit like not quite right, but really, I have already told you what I do at work. So what I reply, my reply is just like, I see. And then I start putting my cursor in the chat windows, and she will see something like Cupid Chan is typing for 7 minutes. Then she finally cannot really tolerate and then said, don't you want to talk to me about it's fine, I'm sorry. Okay, in order to keep this conversation more interesting and longer, I copy and paste my LinkedIn profile into this, very long, but I just type and then copy and paste into that. And then her reply was, wow, cool. So and then I wait, and I keep on waiting. And this time, it's not her being frustrated about not getting a reply, it's me. So when I click on her profile again, I got this. The profile is not available anymore. So fortunately, I captured all the screenshot of the chat before the account is closed. But really, the spirit of this true story about fraud is fraud can be anywhere, including the platform, unthinkable platform like LinkedIn. Someone will come in and try to scam you using fraud. And not many people are like real Frank Abagnale, who turn around and become a good guy and help and serve in FBI for 40 years to really use his knowledge to fight against the bad guys after he realized this is not right. So really, if I really want to come up with this, I want you to look at our title, the section, the title the title of this section again. Look at it closer. Catch me if you can. Can you see that? Can you really see it? Catch me if you can. How to conduct fraud, waste, and abuse using machine learning, presented by Anonymous Hacker. Doesn't matter if it is a good or bad morning, afternoon, or evening. Someone geographically located on the other side of the world is working on a topic like this. And the real reason for that is to make sure that you will fall into their traps. And if we are not using technology to fight against it, our enemies or our competitors will. So keep in mind, this is a very important topic. And if you have any question, feel free to connect me in LinkedIn or Twitter, especially in YouTube, because I know I did not have much time to go through the details of how did I come up with those algorithms, both supervised and supervised, and also the gang network. But I am planning to detail all those approach that I made in the YouTube video. So please, if you get a chance, subscribe my channel and connect me in LinkedIn. And I know another point is my hairstyle is not look like what I'm doing today, because I haven't done my haircut since last year, but I will have my second shot of my COVID-19 vaccine next week. So you will see me back to this hairstyle very soon. Thank you very much. That's all of my presentation.
Thank you, Cupid. That was fascinating. I think for me, those different learning mechanisms were interesting to hear about. We are right at time, as you suspected we would be. Our next session is don't forget ML Ops when deploying AI machine learning models with Michelle Archuleta at 1. So we have a bit of a break here, 15 minutes. If you have time, Cupid, to meet with everyone in the networking area so that they can answer any questions they might have there, that would be great. Otherwise, please do reach out to Cupid via his Twitter or his LinkedIn account with questions that you may have. I look forward to talking to you all again in just 15 minutes. Thanks.